real images that represent real life, or simulated images that only approximately simulate, but in other hand, then we have an absolute ground truth, and image quality then can be controlled more precisely. So we went with the second approach, and this is the algorithm that was realized by using third-party site of PAC-Q simulator. And here is example of this artificial objects, images that was simulated. So as you see, some examples, some easy data set with high signal to noise ratio and low clustering of objects, and vice versa. Hard data set with low signal to noise ratio and high clustering. So, oops, not advancing anymore, but that's not. Oh, finally. Okay, so to collect data, how people segmented and analyzed the images, so we requested specific statistics. So as listed here, quantified statistic, and of course, to collect the metadata, not only quantitative, but also qualitative about what strategies were used. And also we collected demographic data such as education, experience, and other parameters as listed here. So analysis goals in this study was to compare and evaluate these analyses to identify the factors that impact reproducibility, well, such as accuracy of each analysis, variability between analysis, correlation with used methods, correlation with user level, correlation also with the analyst experience level, the people. So we hope that our results will inform the selection of algorithms that are best suited for specific tasks and also matches user abilities. Will aid the refinement of programs to minimize user-to-user variation. Here are current statistics. So we, so far, as you see, recruited 27 participants. Here is the statistics, what software they used, and if they wrote their own code. There is also distribution of people that managed to do easiest data set and the hardest data set. And so as you see, our statistic is not very high, so we are continuing our study and recruiting more people and organizing on April 27th, and show here additional session via Zoom and inviting everybody to participate and also disseminate this information to anybody who may be interested. And finally, here are all our research group members listed, and also some our web page and all the interesting things that are listed there and can be useful for any microscopy. So thank you for your attention.
Was there one question in the chat, Ben, or are we good?
There weren't any questions
Okay.
in the chat. I think I did make an announcement to the people that were viewing it virtually that I think that the images that Aaron showed were probably the first section or first plane of a Z stack. So there's a lot more information in those images that we are analyzing. So.
Wonderful. And we will have time at the end, hopefully, for questions for any. So please grab Aaron or any of the LMRG members or send us an email if you have any questions about that. But hopefully there will also be time at the end of this session. Thank you. So I'm very excited to continue this session today on image management and curation with OMERO and iRODS. And I'm going to welcome Valeria up here. She's an assistant professor in experimental pathology, joining us from NYU. And she's going to share insights into their implementation of OMERO at NYU School of Medicine.
Thank you so much. Is that good? Thanks for the invitation. I'm super happy to present this because we have worked on OMERO for the past 2 years and during pandemic, and we managed to work within a team to set it up. So even though I belong to DART and experimental pathology, we had to kind of like learn the language of MCIT. So I want to thank Kren Castro, who is our main MCIT research person, contact for research. Of course, the Glencoe software team, because what we have is OMERO Plus. So it's not the open source distribution. This is kind of the commercial publication of it. Of course, especially thank Cindy and Sheena, because if they don't have the vision that this is something that we need to use, we would never have acquired it, right? Sorry, MCIT is the Medical Center for Information Technology. So it's the IT department for all of NYU. And they have several teams. So that's Windows, LDAP. These are all their own subspecialty teams. Thanks. Okay, so just to give you an idea of how we're organized so we are at the NYU Medical Center, and it's part of the School of Medicine. It's different from NYU, kind of what we call downtown. So we're completely kind of separated from them. So our campus has most of the research labs within the same buildings, although there are some distributed in buildings far away. We have around 200 or more research laboratories. The people who run them are both very basic scientists and clinician scientists, who some of them have their own lab space, but many of them don't. As I mentioned, we have IT, which is what we call MCIT, is highly centralized. We have a dedicated team that deals with research, but the IT culture in our university at the School of Medicine is to protect everything, because everything is clinical. And so that's kind of the mentality for it. Then all our cores are under one umbrella. So we're a community of cores and we're highly integrated. So we work with each other, and you can see that there's several of them, and we always kind of communicate very well. And I'm from that last one, experimental pathology. So that's where I come in. Just to give you like also an overview, and you probably all have seen this, the kind of the institutional problem that we had was that the image data keeps growing. There are several formats. How do you going to read these formats? Do you have to go to a core to read them? Who has access to them? Then if you're in basic research, you might work with all these formats, and you might be in a lab for around a 5-year period. And so you have kind of a length of time to either learn the technique or learn the one technique that you want to use and know how to use it. But if you're a rotating resident who's doing their residency in the clinical world, and they have like 3 months to do a little bit of research, they're going to depend on, web accessible imaging platforms or digital pathology, and they are not going to spend time learning, one of these programs. And here, our problem is that the user base is very large and very fluid. And so kind of teaching them where data is a big problem. And so where's your image data? And this is true for everyone. It's in a server. Who knows what a server is? I still don't know. A thumb drive on its way to the server, of course. No, it's at the core. What core? It's on Dropbox. Is it on Flickr? And oh, no, we're good. The postdoc who just left knows where it is. So we can contact them and see. So these are like typical questions that I guess everybody has. And then our specific experimental pathology problem was that we are a core that does very different kind of work. So we do a lot of sample processing, then we do staining with different techniques, slide scanning, and now we're doing spatial profiling. And so that means that we give the users access to the images. So everything that was kind of more pathology related, we used to give access through SlidePath, which was a web-enabled visualization tool, and that came to an end of life suddenly without very good notice. So that was like our urgent problem, was to get all that database into a new database. And then because we do these different techniques, we wanted a database that could read them all, right? So of course, Leica, who was the one that had SlidePath, were offering a Perio or some, but that would only work for pathology slides, and that wasn't a good fit for us. So why did we choose OMERO? One, the image format, because of rigor and reproducibility, because you can track your data very well, because there are NIH data management requirements that are coming up, and you need to be able to see where that data comes from, when it was produced, when it was modified, etc. There are publisher requirements, of course. We wanted fair data, and we wanted specifically a scalable system. So we didn't want something in-house. We wanted something that, from people who know how to manage things that grow fast. And so in terms of data organization, you can see that OMERO has this interface where you have an owner and then members, and the owner is usually kind of the PI. The members are the people in the group. It could be collaborators with you, and they own the data and they import it. You can visualize the data, and what I'm showing you there is just different formats. So we have EM, we have whole slide scans, we have confocal data, etc. And eventually it can work as an image data repository. So it kind of checks all those boxes. So how did we do it? So for starters, XPath said, we're running out of time. We need to replace SlidePath now. So Dart said, yes, well, we'll get you OMERO. And then we figured, we cannot do this because, of course, nobody in XPath knows anything about managing these systems. So that's when MCIT came in. And they were excited about this project. They didn't know what they were getting into at the beginning. So we were so glad that because we got OMERO Plus, we had the whole of Glencoe software team so they kind of managed the system and, work with us, right? And so they were incredibly helpful. So that's what we did. And then the things that we had to look for was data, like these are our bigger questions, right? Who owns the data and who takes care of the data? Even after something's published, you want the data to be safe. Who has access to the data and how is it organized? So it's easy to search. And of course, our biggest problem was the SlidePath migration. So this was kind of our timeline. Michelle, you'll give me an idea of when I'm running over. Okay. We acquired OMERO from Glencoe around end of 2019, set up the development server in March 2020, the slide path migration, which thank you, Glencoe, if any of you are listening, was painful, but it worked. We have the data safe, everybody can read it, and we can go back and look for something that's missing. And our production server, meaning in IT terms, it's a production product, whatever that means, was established the middle of last year. And to date, this is just from today, we have 586 users. These comprise 187 labs within NYU, the School of Medicine, and 27 what we call external labs. And external labs can be, you know, labs who are doing research with experimental pathology. That could be Columbia, Mount Sinai, it could be anywhere. Or the dental school from NYU is also considered kind of an external lab in kind of MCIT terms. And so the things that we really had to like think and organize was, how is the data transfer and availability and the read-write access to the data going to be done? So if you look first at our core lab, produces a lot of images, and we have two ways of transferring that image. We always put it into the OMERO server, so that's where it's stored. There is what they call research isolon, which is super secure method of storing data from the IT department at NYU, and that data is always backed up in 3 different places around the US. So it's like safe there. So once it's there, we're happy. Once it's in the OMERO server, it means that if it's visual data, it can be seen through the web interface by every lab. They can also have direct, if they need to download raw data, they have direct access to that storage drive where that data is, but they cannot move it, rename it, they cannot delete it. They can just, what they call in IT, read it, so they can download it to their computer. They can save it somewhere else if they need to analyze it with a specific tool. But the data is safe. The other way that we have of transferring it is through a temporary share drive, and everybody has read-write access to it. And so the last way that I'm going to say, so let me just show you. So this is how we've organized. We basically have an OMERO, kind of the big OMERO drive. And within that experimental pathology, we hope to have the other cores in there. And then we have each lab as it's organized by NYU terms. So NYU has their own kind of internal organization of this, and they manage all permissions through LDAP. So if I say, okay, I want to give access to this lab, and all the members of this lab need access to OMERO, then IT is in charge of giving them the permissions for that. And then specifically the way the data flows is from our core, we produce the data and we use a command line import for putting that data into the OMERO server and making it accessible to the web client. So once we import it into OMERO, it's available through the web interface. Now, if the research lab has their own data that wasn't produced at a core, but they need to upload it, they can go through OMERO Insight. And this is an application that you download to your computer, and then Insight will write directly to the OMERO server, and then they can see it through their web client. And so that has read and write access. And finally, for our external users, since our internal users can access the raw files directly from a drive because they're in the network, they go to that drive and they can download the files if they need them. The external users didn't have that. So we are sharing the data through Globus. So now their, group folder is accessible through Globus, and they can sync that folder and access all their data. And well, does it work? It does. It looks like 2021 was very busy for production of images, but each dot is basically the number of images that are imported weekly into our OMERO deployment. And we're happy because it's a lot of images and they are searchable. So for example, I can go in and say, oh, where's my past staining? And I can bring up all those images right away. And then these are the logins per month. And you'll see that in January and February, March, there were a lot of logins. Those are artificial logins because we were doing data transfers and creating a lot of groups before production. But the normal amount of logins is stabilized. And so we're happy that it does have a lot of use. And what we're currently working on is a public-facing OMERO web instance. This is a huge project because we want to give access without having an NYU credential to data that's either published or for somebody who needs to collaborate with someone who it's a mess to give them an ID from NYU to get access to their data. So this is in addition to kind of responding to the data management requirements from NIH, who the libraries are heading like a whole team to figure out how to deal with this coming January. So it's a really cool project, and it's IT, DART, and the libraries. Now that we're in production status, we're figuring out best ways of monitoring the use and what happens when there are glitches, and where this is kind of work in progress and learning. We need from DART specific do more education for the users on how to import their own data so that they can start using it even more in their research. And of course, it's increasing the number of cores using OMERO so that all that data that's produced by the cores, that's image data, can be held securely in one place. So thank you, and I'll leave it open for questions afterwards.
Thanks, Valeria. That was great. We will, I know there've been monitoring of the Q&A questions in chat, and because I think both speakers might have some insights into some of the answers, we're going to save it until the end of the second one. So definitely keep those coming. Those are being collected, and we really appreciate them. But next up, I want to invite Terrell, who's serving as the Executive Director of the iRODS Consortium at UNC Chapel Hill. He received his PhD in Information and Library Sciences, and I'm very excited because he is able to help fill in those questions of what is a server, all the speeds, and you can hear from the experts now at his first ABRF. So we're very excited he could join us.
Thank you, Michelle. So yes, this is my first time here. I'm learning so many words. I have lots of words, but I don't know your words. It turns out that my job is to translate all these people's words to each other because they're all using different words to talk about the same stuff. And so I'm going to try and communicate some of that today. I had learned about OMERO about 2 years ago as we worked on a project at UNC through Michelle's core. And I think it's amazing, and I don't want to reproduce it, but I think we have a lot to add from where I sit to make them talk to each other. So I'm going to talk a little bit about that process and how we got there, and a little bit about the future. So I work on iRODS. The iRODS Consortium is a fake organization inside of the Renaissance Computing Institute, which is one of 60 or 70 research institutes under UNC Chapel Hill. Whenever we sign legal documents, I don't sign anything. You get in trouble for that. Only the university signs it. You know, we are not a company. We are just a project at UNC. We have people all over the world who use our stuff. iRODS has been around for 25 years or so now. It's got pedigree back that far, originally funded by DoD, DARPA, NSF, NIH, that kind of stuff. Originally started in physics because you couldn't write everything down on a single disk. So they had to do some grid storage, and then your stuff is all over the place and I don't know how to find it. So they had to add a metadata catalog and some policy. And so 20 years later, here we are. Our membership largely includes people who are doing science. So that's, you know, research, pharmaceutical companies, universities, that kind of stuff. Second group is storage vendors who are trying to sell storage into those places. They're best friends sometimes. And then the third group are technology integrators, kind of our boots on the ground around the world. So we train the trainers. I can't be everywhere at the same time. We're a pretty small group. And so we've got people who learn what we do and then maybe, you know, would help you if we're not there, right? That kind of stuff. And so I'm going to talk about three things today. One, what is it that I do? What is iRODS? Second is a little bit about what we did with the neuroscience microscopy core at UNC School of Medicine, and then how that led to our ongoing conversation kind of as a working group with integration with OMERO more broadly. And so iRODS, people need iRODS once they have a lot of stuff because you run into types of opportunities that Valeria was communicating with. Like all of a sudden you have some permission issues and where's my data? And I thought it was over there, or maybe the grad student has it, right? The person who left, the postdoc. And so these things are very standard problems. We had a large influx in the genomics community about 5-8 years ago because they started generating, quote, too much data. It's a great opportunity, right? And now we're seeing the same kind of things with the cryo-EM and the light microscopy. So welcome to the conversation. Here we are. Sorry. And of course, with that comes access questions, how to find it again later. And then of course, the gold standard is to be able to automate this stuff over time. And the bigger you are, the more likely you've bought another company or have multiple labs. What do you say, 187 groups across NYU Medical Center. So that's a lot, and there needs to be some rules in place or you have a mess very quickly. So iRODS sits above whatever you've already got. And the idea is that whatever storage, whatever compute, you talked about LDAP, you know, we can integrate with all that stuff. We're basically the glue code that provides kind of a sane layer into the future to abstract these things. And then above that are different types of clients, different types of software that can speak iRODS. And the reason you would want or are interested in having a layer is because that's where we can control the policy. And if at that point you can make very strong claims about what you want to do as well as what already happened. And that becomes important when you have to make audits or reports to maybe people who are giving you money, potentially. So everything we do is open source. We take a 100-year view on this stuff. We did come out of physics originally, but then we went through kind of our teenage years were through libraries and archives because provenance turned out to really matter to those types of people, to me. So that's what we do. Our architecture is, it's all plugin driven. So the core is very generic. Our goal is to write code that nobody else has to ever really look at, but can be applicable to lots of stuff. So we are basically a protocol, an API, and the bookkeeping that we do. The plugins are where the magic layer is to talk to any particular specific technology. We can encapsulate the intelligence of all these different domains in tiny boxes, which is good. And then we can compose those together to make the policy apply. And so the real goal is, we saw this earlier, configuration, not code. We don't want anybody to have to write this stuff. You don't want to be the expert, that's fine. So we think that we do 4 things well. We abstract the storage layer. So that's the data virtualization. So Valeria talked about an isilon. That's great. We can talk to that. We can talk to S3. We can talk to local storage, NAS, NFS, whatever it is. So we abstract that, first of all, and then we provide a metadata catalog, and that's not just the time that the file was touched or the permissions on it. It's also about any type of user-generated or annotated metadata. So you can put arbitrary annotations on stuff using your words, and then your tooling can come along and care about those words and take action on them using the policy engine and the workflow automation that we provide. So these things tie together very powerfully to be able to do basically whatever you want, which doesn't help anybody understand what this means, but it's a platform. And so we are here to help. We've got our technology integrators to help you understand how to do this, or to build on top of that if there's a use case that we haven't considered yet. And then the final thing is that because iRODS is an open protocol, it can talk to other instances of itself. So it can federate with other instances of iRODS, and now you can draw your administrative boundaries wherever it makes sense for you. That can be at your unit, your core, your university, your government, right? We've got contracts with DODs around the world that do things, and we can't talk about them, but they can draw those layers wherever they need and make people federate through LDAP or whatever whatever authentication system you've got in place. And so that sounds very scary. It sounds like you have to know what you're doing and write stuff down. But we've watched this for a few years, and we now have seen these 8 things are what everybody wants. Not everybody. Whatever you want is probably a subset of these 8. That's our argument. We haven't found a 9th yet. If you come up with one, please visit me after the talk. And the idea is that we wrote the code to provide storage tiering. We have the code to provide indexing, full text. We have the automated ingest to capture things off of instruments, satellites, water monitors, microscopes, whatever it is, right? And then obviously with the publishing piece as well, also a tripping hazard for cores or institutes that have this great infrastructure, and then now they have to share it to external parties. And we've never considered how to do that well. So we find solutions like a Globus, right? They are filling a void in the sense that sharing is hard. We can do some of that as well, but it requires, everybody kind of agreeing to have that philosophy. And so here are the 8 things again, just moved them around a little bit. And then what we've seen recently is that people are having these different patterns. So sometimes you can move your data to where your compute is. You have a giant supercomputer in the basement and you want to do your science. So you move your data to the computer, okay? Or your data is really big. I don't want to move it around. So you ship a little container with some science or math in it, and you say, run this over here where the data already lives, right? A perfectly viable alternate reality. You can also do a little bit of both. The other thing is people like to sync their stuff across clouds or across their data centers to make sure that they're sharing it correctly. And so these are all very reasonable and good ways to do things. And so these patterns are what we've identified and are now kind of talk to everybody and share these words so that people can start using the same vocabulary. So that was a lot of talking for the first bullet. The second bullet is what we did at UNC. This is a read-only local analysis staging policy. So we had a project called Brainy. Here's a picture with lots of boxes on it. The left side over there, that's labeled at the bottom, the Europa data center. This is the RINCE's data center. This would be the equivalent of what Valerio was saying, the MCIT kind of central services, right? So RINCE in this case is providing the kind of long-term storage, infinite disk that you don't have to worry about kind of stuff. And then on the right side over there is the lab. And so that's where the pictures come from. Let's say the pictures come out of the little machine. That's what I've learned this week. And then they go into the disk, right? Well, the idea is that the little disk over there is not big enough to hold all the pictures coming out of the little machine. So we have to have a plan, right? So we do the replication over to the data center. And then what we've built in Brainy is all of these tools, these imaging tools, these annotation tools are running in a cloud in the data center. So they're not up in the sky, but they're kind of over there on campus. They're web-based, they can be command line driven, whatever. But the idea is that the iRODS part is that neuro zone, that little dotted line. And so we're managing the process between left and right, and then allowing things that touch it on the left to be visible from the things on the right, and kind of managing that process. So the design goals for this conversation were about the automatic storage tiering to get it over to the long-term storage. That's the first thing. And then the second was being able to still allow the people of the lab not to have to go visit the data center. They don't want to come over there. The blinky lights don't want to do that. We want to get the data back over to where they can analyze it using the tools they've already paid for and the, in the comfort of their own home, so to speak, right? And then the last piece is manual targeting of files to talk about that publication use case. And so we ended up setting up a few policies, and by policies, I mean little Python scripts that are running on the iRODS platform. And there were basically two pieces. There was an automatic piece and a manual piece. The automatic piece was one of those bullets that I showed you earlier, one of those 8 things that we do already. That's just storage tiering. For us, that's easy. It lands after a certain amount of time or after the violating query is violated. This particular data, it's time to move. So it ships it over the wire to put on the other server. So that's that's the automatic piece. That was pretty straightforward. It loads off of the microscope. It moves after what I think we set it to 24 hours, maybe 12 hours. And then we trim the one off of the local storage. So the local storage does not fill up at the microscope. Easy peasy, right? The manual piece was a little trickier. We had to write some code to do this, but the framework was already in place. And so the idea is that a researcher can tag a piece of data and say, I would like that, please. And then the policy can kick in within a minute or 5 or an hour or whatever. We had a knob for that. And it would stage it back to the local storage and be under management. And then you can use whatever tooling to look at it, analyze it, annotate it, make new pictures. I don't know. What is it that you guys do? I don't know. And then the idea when you're done, you can untag it and it will again trim it off the local disk, be back over in the long-term storage, but now with all the rich science that happened kind of associated with it, right? So the data management, the movement, the permission model, that's all handled by the policy. Here is a page that shows you the things that we implemented. The first 4 or 5 are things that it does, and then the last 8 or 9 are things that it definitely does not allow you to do, which it turns out to be really important. So we've got collections and data objects rather than directories and files. It's just a nomenclature situation. But as soon as something is tagged as being under analysis, we don't want any of this stuff at the bottom to be allowed to happen. If this is tagged, we can't let any of its parents mess with it. We can't let any of its children mess with it. We can't let, none of that stuff is allowed to happen. Only once it is untagged and no longer in processing or in analysis, then those things can happen again. And what's important is this is happening at the virtual namespace layer across wherever your data is located. In this particular example, the data was only on the lab or in RINC, but we could also have the data in California. We could have the data in Florida. It would protect it at the logical namespace, not physically where it is, right? So once it's under a collection and it's tagged, nobody can remove it until the analysis is over, wherever it lives. So that was the second bullet. And then the last bullet's about the future. So we're going to talk about bringing some storage abstraction to the OMERO tool. So iRODS has a few different working groups around the world. We've got, I think, 4 or 5 now. The most recent is the imaging working group, and it took off by far faster than any other ones we've started. We definitely tickled a nerve, and all these people showed up. So look at all these people with all their words. So immediately there's something going on here. There's a need for wanting what OMERO provides, but with kind of the backing confidence that this stuff is handled and in a distributed manner, and also continuing to be open source. So I made this little picture. This is version 2. I think there's now going to be a version 3 on the next slide. But this version talks about how there's 2 sources of truth now. We have these great pieces of software. They don't know about each other. They both think they're in charge. Ooh, that's kind of a problem when you want them to play together, right? So if you tell one something, it has to kind of inform the other one. You have the 2 sources of truth problem is a real problem. So the idea here is what this is trying to diagram is that if something happens in OMERO, it would use the iRODS API and tell it also. That's cool. And if something happens in iRODS, we would tell OMERO about it. Okay, that works. And then down at the file system layer, we would kind of swap out what OMERO thinks is its own storage, but actually it's just looking at a mounted share that is run and managed by iRODS. Okay, all good, fair enough. But the problem is that still now you've got code in both places that have to kind of track and sync and understand each other at all times. And that's generally not a good design. It's got a bit of a what we call a code smell. And so kind of version 3, I think where we've gotten to now as the conversation kind of evolved is to design some kind of sync agent that sits between these two things in charge. And all the logic about how these two should play together can live in one place. And that way they can always be versioned together and kind of get smarter together. And so any edits or annotations or things that happen on the OMERO side can trigger whatever that means should happen in iRODS. And we're still kind of discussing what that looks like, whether that's the manual save as button or every time you zoom in, does that count as an event? Maybe not. Every time you change the focus, whatever your words are. Those types of things probably don't constitute a new save, but maybe they do. I don't know. We're going to figure it out. And then the same thing on the iRODS side. If somebody annotates something in iRODS or makes a replication or chops something up or divides it, should we tell OMERO about that? Well, maybe, probably, but not all the time. So we're kind of working through those. But having a place in the middle where that logic can live and evolve as we get smarter seems like a better architectural approach. And so that's all the content I've got. But the idea really is that if you're going to do proper data management, it really has to be about having policy. Otherwise, you end up with the postdoc who left, the thing under the desk, and that kind of stuff. The other truth that we testify to is that these policies will change. The technology will change, the people will change, the leadership will change. Different opinions about what we should be doing changes. And so, if you're not honestly assessing that that's part of your reality, you're going to be in a situation later anyway. So understanding that the policy will change means that you're going to have policy. It has to be flexible and it has to be able to change over time. And then obviously the open source argument is that this is the best way to do it, to collaborate with the most people. Thank you.
Thanks, that was great. And everybody is on time, so we still have a lot of time for questions. I know we have some from the chat, so maybe we'll start with that. But if you guys, I think we can see you if you sit here, and these mics should be live. That we can test that, but go ahead, Ben. And then anybody in the room as well, we have a mic that we'll also share to all the virtual participants. So just put your hand up as we go.
All right, thank you. So we have a question from Elke, and she says, this is for Valeria. Is the OMERO server managed or maintained by Glencoe or by your local IT team?
I think it's a combination of both. So Glencoe would be the main manager of the server. And so they do the updates, they restart microservices if needed, but they're slowly kind of teaching us how to do it, which is great. And so when something happens, and we need a fast response, MCIT and our institution can do certain kinds of like restarting processes so that it would fix if it's a little glitch.
Can I ask a related follow-up question then? So is your long-term goal then to kind of be independent, independent operators, or do you expect to use the OMERO Plus service?
That's a bit of a stretch.
Okay, yeah. Right.
Yeah.
And then I guess another question that Elke had was, are you happy with your upload and download speeds for large data sets?
So that's why we established access to the drive. So the drive is when you open Finder or Windows Explorer and you look into, so all our researchers have access to that so that they don't have to download data through a web interface, because it just doesn't work. What they do download through the web interface, and it works very well, is when they do figures, either using OMERO Figure or if they're using Glencoe's Path Viewer, and they're making figures out of that, and that works perfect. And you can download full quality TIFF in zipped formats or just a PDF if you're doing a quick presentation. So there's several options for different people.
Thank you.
Hi, thank you very much for the presentations. For you, Valeria, you have this system in which, the way I understand it, everything that is generated by your core goes into the server to live there forever. And so the data retention policy is infinite, or is there an idea that at some point there will be a purge? And that also relates to the data that are generated by independent operators, so to speak, laboratories. That is there any policy there that, or is this in the works, a policy that says you have to actually deposit it, or is very much left to the will of the independent operators?
So I will give you kind of what I understand about it. It's not necessarily the truth, but so our research data, whatever it is, images or not, lives in, and it's, you know, what IT has been pushing for is that it will, that it will live mostly on what they call the research isolate, where it's stored forever. And if it hasn't been accessed for 3 years, it goes into what they call like deep storage or tape or glacier, whatever they want to call it, right? So from what I understand, it's there forever. Now, if somebody's collecting data on a computer and they're not putting it in that research drive, that's up to them. There's little way of like, you know, chasing people after. But I would say that mostly, since as long as the research drive is readily accessible, the connections are fast, people are going to prefer that, right? Yeah.
So the follow-up question is, who's paying for all of this, and who is there another charge to the clients of the core or to the investigators for putting that in, or is something that NYU, its forward policy has decided to pay upfront?
So I will tell you that the core is not charged for storing the data, because this is, we produce the data, we're in charge of it, but this is kind of, I guess, NYU data. So we're not charging, the cores are not charging the users for the data that's being uploaded. That might change, might not. Right now, there's no charge.
I will say that I've seen different universities implement it different ways. The library approach, centralized library at the university, has taken a larger role in many places because they're realizing that this is, you know, the gold standard, right? They have to have this in terms of being able to reference again back to it from publication data, as well as the policy about the retention policies. This is also very important, right? So you've got grown-ups making decisions that may change over time.
Thank you. So NYU decided a number of years ago that they would, you know, the decision was the institution owns the data, they will store the data. And so every year we have a discussion in terms of what that cost would be. I imagine that a few years down the road, there will be a cost, but I think it also ties into the release of the new data management plan with NIH.
Right.
I had a follow-up question about the cost. So it's great that you have this institutional support. Do you think you can speak to the total cost for the OMERO Plus platform and or any hardware associated costs as well?
I should have looked at those numbers before this. I'm sorry. I don't want to make up numbers out of my head. I do know the costs. I mean, my computer knows the costs, but I cannot really bring them up.
That's okay. Thank you. And I have one more question too. In terms of your clinical users, how have they found the transition from your OMERO Plus system from SlidePath? Do they like it? Do they think it's just as good, or are they having a hard time?
No, I don't think they're having a hard time, because OMERO Plus deployment that we have has an extra, when you click on one of those image thumbnails, it reads if it's a whole slide scan, and it will open up in a new tab in an app called Path Viewer. And path viewer is very similar to any of the pathology viewers. What I think they're starting to appreciate more and more is that they're getting to see fluorescent images and they don't have to come to the core to look at them, or they don't have a special. So, and the younger pathologists are, you know, they're super easy. And what we're doing a lot is, so we have a geomics instrument and we're getting the pathologist to annotate in OMERO, and then we can, you know, translate. And the other thing that has been like incredible has been that this a pathologist annotating mouse histology pictures that a particular lab is producing, like they're studying cancer metastasis in the brain. The pathologist then annotates them in OMERO. Those annotations are exported and together with the images to a bioinformatics center where they're training their neural networks to learn from those annotations. And having a centralized kind of viewing system for this is, so yeah, so that was, yeah, it grows.
So I had a question around, I guess, again, data intermediates for when you are generating a bunch of different neural networks or different, I guess, any processing pipeline. So what we've run into at the institute I'm from, NCATS at NIH, is that from a single, let's say 1 terabyte data set, will generate something like 50 terabytes of intermediate data. And we're saving all of it, but the less than pleased with like a 50x increase in data storage. And so setting up nuanced policies has been for data management has been something. Okay, you can hear me again? Okay, cool. Yeah, so really nuanced data management policy has been something that we've been really struggling with, because it's not just okay, this is your raw data, nobody's touched it in a year. It's more like, okay, you know, you just generated 40 different outputs from your neural network, and you want to compare them, and you're using them a lot for the next 2 days, but then maybe you don't touch them again for the next 6 months, but then maybe you want to load them up again in 6 months when you're writing up your publication, et cetera, et cetera. And so moving things back and forth to and from cold storage and then doing this across labs has been like a huge problem, I guess. And I was wondering how nuanced, I guess, in iRODS the data policy management can get, and then also like how technical you have found that the users to need to be able to implement or correctly implement those data policies.
Yeah, excellent. So it can be as fine-grained as you want. iRODS, because it's a database keeping track of all of the truth, it's queryable. And so whatever system makes sense to you, you can build in sense of naming things well and finding it later. If naming the pipelines, if naming the stages is important, if you find that useful, then you can have policy that can key off of what stage something is in. If finding out physically where something is matters, then you can annotate that and make that part of the policy that kicks in and says, well, we put it on what we call temporary storage. That's just a label, right? It's still just a disk somewhere or a flash array or something. And so it can be as detailed as you want. And in regards to how technical you need to be, if you're the first one into the weeds, probably you need some help. But now that we've written the thing for Michelle, nobody else has to really think through that again. We've got the test suite, it's there. If you want something that's similar to that, those are off the shelf now effectively for us. So as we see more and more use cases and we build the policy sets that make sense, and if we do it in a generic way and make them label driven, you know, you don't have to use the same labels that Michelle does, but the same idea can happen. You label this, something happens, you know, it stages it over here. It removes it, it deletes it, it trims it, whatever. Does that answer the question?
I think so. And so you're saying as fine-grained as you want, like down to the metadata values or the files?
Down to either one. Yeah. So you can label anything in the system, and then those labels can mean something to your policy. You can label collections, you can label files, you can label parts of files. You can't label labels, I guess, but
Yeah. So then what becomes metadata is also really relevant in that question, right? Because annotations could be considered metadata,
Yes.
but then they could not be. And so where do you draw? Yeah, like where do you draw that
yeah.
line?
So we don't, because we can't know what you might think is important ahead of time. But you can definitely design a system where you've got, 4 buckets of a pipeline or 20, right? And as things move through that, you can annotate it and say it's in this stage, or it's in temporary, or it should be in temporary. And then things can wake up over here and move things around, or trim things, or chop them up and prepare them for the other pipeline, right? So there was a comment about, producing other products for another core or for another workspace in a different format. So those conversions are also fully automatable, especially if there's open libraries for open formats. Yeah.
As I walk this over to Ben, I just wanted to comment, kind of translate what Terrell had said. What we're working on right now is an automated import from the microscope where it's tagged as raw. It goes to a long-term storage place. Other maybe automated stitching happens. Only that file gets moved to OMERO. So the users are not seeing as much duplication, and it's doing the automated trim and publish. Same thing for publishing. Only the raw will be saved. It's linked to each other, but the only thing that gets published on the published one is the very final data with the metadata included.
Yeah, if we do our job right, the researchers don't have to care where anything is anymore. Just about kind of the state of what something is in.
Sorry, I know it's conscious of time. Lunch is after this. We have one question we wanted to make sure we got to on the virtual, but I know that it's tight and you can catch them in person or by email as well, but I'll hand it to Ben for the last one.
Okay, this is another question from Elka. This is for Terrell. iRODS is an open source, but your services much incur costs. Do you charge users for your services?
So we don't run iRODS. First answer. We help you run it, and we provide service and support contracts to train you, to teach you, to help you swim. We don't actually offer a Glencoe-like service. We don't run our own services. So it is open and you can play with it. You can dip a toe in it as much as you want. We're happy to help. You don't have to buy into all of what we're pitching. You can do a little bit as you want. And then if that convinces you or convinces one of your colleagues, we're happy to help spread the word. So yes, it is open source. You can play for free. And then we've got, our memberships are at the end of our funnel, so to speak. We get people into membership, and that helps the community keep the lights on.
Thank you.
Thank you all so much. I'd like to thank both speakers and the LMRG and all of the organizers. So thank you all for coming and participating, and please feel free to reach out to any who presented today. Thank you all.